Now let's see one kind of a latch. We can call it as SR latch. We can call it as generally set reset latch. Set reset latch. Right? Guys, basically how we are going to represent a memory element? We can able to represent with the help of either NAND gates or with the help of either NOR gates. For example, I am trying to represent with the help of NOR gates. With the help of NOR gates, your input will be like this. Like this. So here you are going to get Qn. It should be Qn bar. Should be Qn bar. And this input, this output, you are going to be connected to the input here, as well as this output, you are going to be connected to the input of top level NOR gate. NOR gate. And here you are going to have one more kind of inputs are there. Right? Earlier what happened? Earlier we have given a circuit. That circuit will act as a kind of a memory element. But actually in the real time, do we need to change the inputs or not? I mean, do we need to change those location values or not? Meaning that instead of changing the 0, I want to change it to 1. Or instead of having the value 1, I want to change it to 0. Or I want to put the same value there itself. So means I need to control that from the outside. If you would like to control that from the outside, compulsory I need to have external inputs. Right? Compulsory I have to give the external input. Those external inputs I am going to give it through these two lines. These two lines. If I am going to give via one kind of AND gate, observe here, one kind of AND gate where this is R and this is S, R and S. And if I am going to give the input like this, what will happen, guys? R can give any input, S can give any input. Now the flip flop is going to, the latch is going to work accordingly. Latch is going to work accordingly, right? But I want to have some control over this entire circuit. So what I will do now? I will try to make it connected over one control line. One control line. I can call it as a clock signal. I can call it a clock signal. This clock signal is what now? What is the meaning of this one? Positive level clock signal. Right? Positive level clock signal symbol is a single parallel line. Single line. So I can call it as positive level clock signal. Right? If I am going to pass single level positive level clock signal, I can call it as a SR latch. In place of this positive level signal, if I pass some kind of edge triggering, what will happen? It will be acted as a SR flip flop. So you have to make sure understood, right? So as I am trying to control this entire circuit with the help of this signaling, I can call it as this one as synchronous SR latch. Synchronous SR latch, meaning that my entire control circuit working will be depend on one particular point. What is that point? This one. This one. I can call it as synchronous SR latches. For example, I am trying to draw it in another way. Now this one, can I call it as synchronous clock, synchronous SR latch? So this will be R and this will be S. This is what I can call it as asynchronous SR latch. Why asynchronous SR latch? Because the inputs are going to be given at any values, at any point of time. But whereas coming to synchronous SR latch, what will happen? When the signal is positive signal, then only our circuit is going to be active and it is going to work perfectly. Whereas coming to in asynchronous SR latch, there is no point of about controlling. There is no controlling here. Whereas coming to here, definitely there will be a kind of control. There will be a kind of control. I can call it as synchronous. Right? Now try to observe how it will work. Guys, can I write the same thing in another manner? How can you write? So can I do it with the help of NAND gates? Yes or no? I can do with the help of NAND gates. This is Qn and this will also be qn bar, and this input I am going to pass it from here, and this input I am going to pass it from this particular expect location, and I am going to give the inputs externally because to make modifying the memory, I am trying to give it from the external inputs, but here right now I am trying to give the inputs using NAND gate only, this is OR, and these two are going to be controlled by one signal. I can call it as positive level signal. Now can I call this as SR synchronous SR latch or not? I can call this as a synchronous SR latch. Similarly, how we are going to write the asynchronous SR latch? Using NAND gates, we can write like this. So this should be Qn bar and it should be Q bar, and this will be connected like this. Right? So this is what asynchronous SR latch. If you are able to observe from this point to this point, I can basically call it as a latch only. But the point is here I need to combine these two into a single input, right? So if I want to control the memory, I am going to give it some input from the external side. But that controlling also controlling with the help of only one particular point of time, I can call it as synchronous. If that inputs are not going to be controlling through one single point of time, I can call it as asynchronous, right? So if somebody asks you to write SR flip-flop, can you able to do that? Yes, right? So what we can do? So basically, if I say here as like this, now can I call this as SR flip-flop? Yes or no? So if I say here as a single positive arrow, I can call this as SR flip-flop, right? But there is no point of here latch as well as flip-flop, because we are not using here directly controlling lines. We are directly giving the inputs. For example, I want to have the input. Can I give the input like this? I can give the input like this also. But what is the biggest one? This SR latch or this SR flip-flop is going to work on under water condition. Under the negative edge triggering, it is going to work. Right? I can define like this also. Similarly, can I represent in another manner? I can represent in the form of negative level. Right? So don't write all the things for one circuit diagram. Okay. For sake of our understandability, I am trying to explain here. So I hope you understood the difference between latches as well as flip-flops. Right?